One of the major tools of a forensics laboratory when they try to investigate, evidence and crime for crimes is a microscope. And here we're going to learn a little bit more about what that is and how it's used. Well, you know what a microscope is. It's that thing you put your eye in, you look through it, and tiny things become huge, right? You can see little tiny things in. You know what a microscope is. I'm not going to show you a picture of it, at least not yet. And you probably also know that you adjust the lenses of the microscope in order to get the things to become bigger and smaller, and also to make sure it's very clear. Okay, fine. The simple stuff I'm not going to go into. The microscope, again, one of the simple things that you probably know is that each lens has a certain level of magnification. One might be 10 and the other might be 40. When both lenses are put together in the microscope, as they are in a microscope, the 10 is multiplied by 40, giving you a 400 times picture. So you can see something that's really small, it'll be magnified 400 times, or 10 times and a 30 times, or 10 times and a 45 times. That'll be 450 times the original size. So you would ordinarily think that all you care about is how well you magnify. The bigger it is, the more you can see the details. But there are other things that have to be that must be kept in mind. There's also the numerical aperture. I'd rather not go into that too much, but that has to do with how clear and how well focused and how visible the object is when you multiply it when you multiply it by whatever the magnification is. The bigger it is, the greater the focus that you have. Meaning the more visible the focused object is, and the more resolved it is. Meaning the more easier it is to differentiate between two different things that you're viewing in the microscope. The fact is that the numerical aperture, if you multiply that by 1,000 times, the magnification you'll get will be useful. But if it's past 1,000 times that, it's probably going to be too blurry. Even though it's bigger, it'll probably be too blurry for you to get any useful information out of it. So that's numerical aperture. You have to make sure that that's pretty good. Assuming that we're not using any oils or glycerin or some other method of increasing the numerical aperture, it'll get from between 0.25 to 0.95. But again, we're not going to be dealing too much with it. You should just know that the numerical aperture just enables it to become clearer, and you have to have a good numerical aperture to be able to see what you want to see in the evidence. The things that are a little bit more understandable, that I can go into a little bit more, would be the magnification and compared to the field of view. Now, you might think that just increase the magnification, you'll get more information, but that's not so simple. Imagine you are trying to magnify, let's say, a needle held in your hand. So if you have a low magnification and you want to see how the fingers are holding this needle, you will have a large, what they call field of view. Here's the field. Here, imagine that this is what what you see through the round slide, or the round sample area of your microscope. The field of view is what you have inside it. And if this is really big, you can get a lot more in there. And the example that I was giving, you'd see, let's say, your finger and your thumb holding the needle, and you have information on the finger and the thumb as well as the needle. Now, if you increase the magnification, you're going to only see, let's say, the tip of the needle. You will not have any information on the finger and the thumb that are holding it. So the more magnification you have, the lower the field of view. If the low magnification, multiplying, let's say, 10 times, you'll see the finger and the thumb. They will appear in this field of view. But if you magnified, let's say, another 20 times, you can only see the needle, then you're going to see the needle inside this field of view, and you're not going to see any of the thumb or the finger. So the more magnification you have, the lower the field of view. You'll be able to see it less. So it's not always true that you just want more magnification. Sometimes you want to see the needle. Sometimes you want to see the finger and the thumb that holds it. And that really depends on the the specimen and the evidence that you're looking at. If you're looking at a single fiber, you really don't care about what's going on anywhere outside the fiber. If you're looking at a bullet, then you have to have the entire bullet, or at least most of the bullet, inside your field of view. So it does matter not just magnification. You have to have a good enough field of view. This depends on the subject that you are analyzing with a microscope. Now, this, I said, field of view is what you can see all around in the view of your microscope. However, this is only from side to side. There is also what they call a depth of focus. If your field of view is only, let's say, from here to here, and let's say that contains the tip of the needle, up and down also, your microscope will not be able to get much more of a distance than you have between from side to side. If the tip of the needle is 1 micrometer, you'll only be able to get information 1 micrometer deep from that tip of the needle. So you will not be able to get the back of the needle that has the thread, the hole, and the thread going through it. You'll only be able to get the tip of the needle. So the field of view and the depth of focus are related in that way, that the field of view has to do with side to side, and depth of focus has to do with going up and down, how much you can see. And again, this depends on what you are looking at. Do you want to only look at the tip of the needle, or maybe you want to get information on something that's a little higher and lower than the tip of the needle? That really depends on what you are trying to look at. But you should know that the greater the magnification, the lower the field of view, and the lower the depth of focus. So if you have a less magnification, you'll be able to see up and down also. This really all depends on what you are looking for and what kind of evidence you have. So you have to choose a level of magnification and also the depth of focus as well as the field of view. You have to understand what you are trying to look at and adjust your settings of the microscope, or perhaps get a different microscope depending on what you want to see. There are 2 microscopes that are used a lot in the forensic laboratory: the comparison microscope and the stereoscopic microscope. Now, the stereoscopic microscope is probably easier for you to notice. The classic idea of a person looking at a microscope is a person having one eyeball right into looking at the top of the microscope and seeing what's on bottom. The stereoscopic microscope has 2 eyes, has a viewer for both eyes. So I would assume it's a lot more comfortable for people to look at something using with 2 eyes instead of like looking through only one eye. The other thing about the stereoscopic microscope is that because you have 2 eyes, you have binocular vision and you can see a 3-dimensional view. Just like when you have 2 eyes, you can see a 3-dimensional view of what's in front of you. Also, when you have a stereoscopic microscope and you're looking at it with 2 eyes, you can have a more 3-dimensional view of the piece of evidence you're looking at, or whatever else you're looking at. The stereoscopic microscope is the one most commonly used in forensic laboratories. Here's a little bit. We're going to look at this picture. Here's where you see it. You put your 2 eyes there like it's binoculars, and you'll be able to see, through these views, what's going on in here. The fact that you have 2 of them, we'll talk about that soon. But the point is, stereoscopic means you have 2 eyes, and they are both be focused on whatever this thing would be. The other idea is the comparison microscope. That enables the forensic examiner to look at 2 things at once, because that's very important. Let's say you want to compare a bullet that was used in the